In the previous video, we had discussed about Manning's equation, one of the most important equations for open channel flow. Now here, the quantities such as the velocity of flow, the hydraulic radius, as well as the slope are possibly measurable, as in precise values of these quantities can be obtained from measurements. However, the Manning's roughness coefficient is one parameter that has uncertainty associated with it, and a fair amount of subjectivity lies in its choice. Now, the way we had noted this equation in the previous video, this hydraulic roughness was purely because of the hydrodynamic roughness. However, in real channels, whether it is natural or whether it is man-made, the roughness coefficient N is also influenced by conditions such as whether or not vegetation is present in the channel, whether or not there are bends, meanders, or several other types of obstructions. Depending on all these factors, the Manning's roughness coefficient has to be carefully chosen for in real life channel. So let us look at some of these factors which influence the choice of N. Those can be irregularities in the channel cross section. So when we have large irregularities, this implies that the Manning's roughness tends to increase as compared to a smooth channel. If we have obstructions such as non-living obstructions like logs or other pieces, or vegetation, for both these cases, presence of these obstructions tends to increase the value of Manning's roughness coefficient. If we have presence of bends or the channel meanders, then also the Manning's roughness coefficient tends to increase. There's one more point that I need you to note here. Manning's roughness coefficient N in real life also depends on what are the existing flow conditions within the channel. Typically, if we have larger depths and discharges, even in the same channel as compared to the situation where the depth and discharge are smaller, the Manning's roughness coefficient tends to decrease. So when we have more flow, more depth within the channel, we expect the roughness to be lesser than what we would expect if the flow is lesser. Alright, so what can be some of the guidelines to choose a precise or a correct value of Manning's roughness coefficient? And here there are certain guidelines available. The first one is using pictorial representations. So by observing real life channels of different shapes, sizes, and within each channel, people tend to observe different depths as well as discharges also. And then a library of sorts is created with several many images, such as these. So we have a library of images. And for each of these channels, N is measured. Now, when a field engineer goes to the actual site of concern, so this is the channel under consideration. From the image it is hard to see, but this is roughly a trapezoidal channel. So we have this slope here, followed by the horizontal, and then another slope. So if this is the channel of my consideration, then I would note what are the characteristics that are existing in the channel, and then I would refer back to the library to see which of these already measured and well observed channels correspond to the channel under consideration. And in this particular case, this is found to correspond to another channel for which the channel cross section, the different depths of flow, as well as the hydraulic roughness properties are all measured. And so therefore, referring back to this image, so this is my reference channel now. Referring back to this channel for which these properties are known, we tend to estimate the Manning's N for the channel under consideration. So from the reference channel, we extrapolate the value of Manning's roughness coefficient for the channel under consideration. There are other existing methods to estimate the value of N for a given channel, and those are analytical methods. For example, the one shown here. So NB is actually the baseline Manning's roughness, which means it depends on the material and the channel cross section, and this is what is governed by channel, material and cross section, assuming that the channel is straight, long and uniform. And one such empirical method for calculating NB we had already noted earlier, namely the Strickler's. So this is an empirical equation where the Manning's roughness is related to the median grain size of the bed material. So likewise, you can use other empirical relationships to arrive at the baseline roughness coefficient. Now add to this baseline value, we do add some correction factors. So the first one is changes in cross section. Second one can be obstructions. Vegetation, and so on. And we also use a multiplicative correction factor. This is for meanders. So we can apply all these correction factors to the baseline value to arrive at a more precise real-life estimate of the Manning's roughness coefficient. There are some guidelines which are established as industry standards also. Like for example, the Bureau of Indian Standards has a code which is IS 7112, and this is particularly given for irrigation canals in India and those that are unlined. So for unlined canals in alluvial soils, this particular BIS code suggests some criteria based on which one can select the Manning's roughness coefficient. In the next video, we are going to continue the discussion and also extrapolate it to find out the value of Manning's roughness coefficient for not just the riverbed but the surrounding floodplain around it. And we'll also do some small examples. See you.